Hey guys, my name is Trevor Sullivan. I am a solutions architect with StratusGrid, and I'd like to welcome you back to the StratusGrid YouTube channel. Our company is an AWS consulting partner, and we deliver a lot of interesting projects around custom software development, cost optimization in the cloud, infrastructure modernization and optimization as well, and application modernization. So moving to things like serverless or container-based solutions. So if you're interested in engaging with us, you can head over to our website here at stratusgrid.com. You can click on the little Let's Talk button here and fill out this form on the right-hand side, and one of us will get in touch with you and figure out what kind of projects you are attempting to achieve. Now, in this particular video, I wanted to dive into a couple of topics. First of all, we've got the Amazon DynamoDB service, which is a NoSQL database engine that is proprietary to AWS. It's also sometimes known as a document storage engine. So you can kind of put away the concept of relational databases like Postgres or Microsoft SQL Server or MySQL and other types of relational engines like that. A document storage engine is very different. You can kind of think of it as basically just a JSON object that you're storing inside of a database. Now, the APIs themselves don't directly map to JSON data structures. There's a whole bunch of details in the APIs that you'll have to familiarize yourself with, but that's what we're attempting to do in this video. We're actually going to be using the SDK for Rust for AWS in order to interact with this service. So if you want to learn more about DynamoDB in general, you can head out to aws.amazon.com. And if you navigate over to products here, they've got all these different product categories here. But if you go down to database, then you'll see that the Amazon DynamoDB service is right here. There are a lot of competing solutions that are actually open source to DynamoDB as well. For example, you can see right here that MongoDB is actually hosted in AWS. There's also Apache Cassandra, there's CouchDB, and a whole bunch of other open source projects that can implement a very similar data structure as DynamoDB. But the key benefit with DynamoDB is that it's a fully managed database. You don't have to spin up any servers. You don't have to monitor those servers. You don't have to patch those servers. There's no downtime to patch any servers kind of behind the scenes in the cloud like there is with RDS and other managed database services. So the DynamoDB service is a really great way to store certain types of data. Now, the DynamoDB service has been around since about January of 2012, so it's not one of the earliest AWS services back in like the 2006 era when S3 and EC2 came out, but it has been around for quite some time now. So we're going to be using this service, but again, we're going to be using it with the Rust SDK. So if we go out here and just search for Rust AWS, you can see we've got the landing page for the AWS SDK for Rust. This just went generally available, so it's kind of a stable production-ready release in November of 2023, which is pretty recent as of the recording of this video at reInvent for AWS in Las Vegas. So it is pretty new. And if we head out to getting started here with the documentation and go under code samples right here and go to actions and scenarios, you can actually see that for some of the more popular services in AWS, this is definitely not a comprehensive list of every single service, but popular services like DynamoDB, for example, there are actually code samples here on how to create a DynamoDB table. There's also other documentation or code samples to put an item into a table. So once you create a table, then you can immediately start inserting items into that table. So this shows you the code sample for how to actually insert an item or a document, kind of a JSON object, so to speak, into that particular table. Now, the example that I want to use in this particular video is building out a very, very simple product catalog. So I don't want to get too deep into the weeds in the data structures here, but I did want to start by showing you in the US West to Oregon region right here, I've actually got a table that I've already created using the Rust SDK called Trevor Products. And one of the cool things with DynamoDB is that you can go ahead and just create a table or manage tables, like delete tables, change the pricing configuration of them for provisioned IO and that kind of thing. But you can also explore the table items. So that little button right up in the top right corner allows us to go in and actually scan or query for items. Now, scan operations are pretty inefficient because it actually requires that the DynamoDB service go out there and look at every single record in the table and basically retrieve them and match them to any filters that you have here. But if you use the query-based approach, then you can actually enter what's known as your partition key right here, and that will allow you to retrieve data from a specific partition. And if you have a sort key, you can also limit the results based on the sort key value as well. So when you are building out a DynamoDB table, like over here in the Northern California US West 1 region, I don't currently have any tables here, but if I go to create table and you give the table a name like Trevor-products, again, that's not going to conflict because it's in a different region. You have the option to set a partition key. So you could kind of think of that as allowing you to divide your data across different nodes in the backend DynamoDB cluster. So for example, we might have something like a product category that serves as our partition key. So that way, if we have, let's say, living room products versus outdoor products versus kitchen products as categories, when we create those products or those items inside of our DynamoDB table, the DynamoDB service will use that partition key to determine where to place the actual data behind the scenes on the nodes that are backing up this DynamoDB cluster. You also have the optional sort key. So the partition key is mandatory. You have to have a partition key. And generally, you want a balanced partition key where you have roughly equal parts of your data in each partition. So if I had 50 products in kitchen, 50 products in outdoor, 50 products in the living room category, then that would be a perfect partition key for the DynamoDB table. But with the sort key, we can actually further identify individual items. So in this case, we don't want to accidentally overwrite our key with category because we're going to have a bunch of different named products. So what we're going to do is say, all right, the category like living room or kitchen is going to be the partition key, but within that partition, we also want unique names of individual products in our products table, right? And so together, the partition key and the sort key make up what are called the primary key, or basically how you access a specific document inside of a DynamoDB table. Again, you don't have to specify a sort key, but in a lot of cases, it's going to make sense to have one. Now, we're not actually going to use the AWS Management Console to create a table. Remember, we just looked at the Rust documentation for AWS over here, and we saw the code samples to actually create a table. So once we import the crate or the library in Rust for DynamoDB, we're going to have automatic access to all the DynamoDB APIs to manage the tables themselves, as well as to manage the data inside of those tables. So what we're going to do is spin up a brand new project. We're going to get our credentials set up so that we have access to the DynamoDB service using our AWS credentials that we'll specify. And then we are going to go ahead and actually write the code to create a table, to add products or items into the table, and then also to query the table as well. And the DynamoDB APIs can be a little bit confusing. So there's some deprecated APIs that have been replaced with newer ones. There's also a lot of references in the DynamoDB documentation. Let me just do a search for DynamoDB service docs here. You'll oftentimes see references to things like a high-level API or a document API. And unfortunately, those APIs are not always going to be available. So if we take a look at higher-level programming interfaces here, there's a document model, but that's only available for .NET. There's a mapper client as well that's only compatible with Java. And so we're going to be actually using the low-level interfaces here, right? We can't use document interfaces, we can't use object persistence, and we can't use high-level interfaces because the Rust SDK for AWS simply doesn't support those. So we're just going to stick with the low-level interface, which gives you the most control over the data inside of your Dynamo table. We're going to call the put item API, which is going to allow you to store a new object inside of your DynamoDB table. And so we're just going to do all that from scratch. All right, so what we're going to do for starters here is to just spin up a new project. I'm going to be using Microsoft Visual Studio Code as my code editor here. Of course, Rust source code files are just plain text files, so you don't have to use VS Code if you don't want to, but it's a very popular code editor, so I strongly recommend that you use it. It's cross-platform, so you can run it on Linux, Mac OS, and Windows and have a consistent development experience. Now, once you've got Microsoft Visual Studio Code installed, there's actually an extension that you can install from the marketplace. So if we go over to extensions here and do a search for Rust right here, you can see that there is a Rust Analyzer extension. You don't want the Rust extension, you want the Rust Analyzer extension. And this is the extension that provides things like code completion and automatically inserting imports or use statements when you're using certain child modules or specific data structures or functions inside of a particular module. It'll automatically insert that kind of stuff for you. So I strongly recommend that you use the Rust Analyzer extension because that'll just improve the efficiency of your coding. All right, so let's go ahead and set up a new project. So I'm going to fire up a terminal session here, and we're just going to go into my Git directory. On a Windows system, I typically like to go to the root of my drive here and just have a Git folder so that it keeps my path really short. And we're just going to say cargo new. Actually, before we do that, I'm just going to do a rust up check here. This is just a really good practice to make sure that you're on the latest version of this stable tool chain here. So of course I am. And if I do rust c-version, check my compiler version, I can do cargo -- version and just make sure that I'm running the latest tool chain here. So that's a good practice just to make sure that everything's up to date. But now I'm going to do a cargo new, and we'll call this AWS DDB -products. All right, so now I'll just do code, and we'll say AWS DDB products, and that'll open up a VS Code window here so that we can start editing our source code. If you hit Control-Shift-X, or on Mac OS, it would be Command-Shift-X. Just do a search for Rust over here. You should see the Rust Analyzer extension. Of course, I've already got it installed here, so I have the option to uninstall it if I don't want to. I can also switch to a pre-release version if I want to have a less stable but more feature-driven approach to the Rust Analyzer extension. But generally, I just like to stick with the current stable version. Back over here in our Rust project, we've got our standard src folder with our main.rs file, and we've also got our raw cargo.toml, which currently doesn't have any dependencies. Now, with Rust projects, as you may have seen in some of my other Rust videos, when you are programming with the AWS SDK, everything is asynchronous. So everything is going to be async Rust. So back in our main.rs file here, we want to turn the main function into async, but we can't actually do that unless we have an async executor. And one of the most popular async executors out there is called Tokio. So down in my terminal here, we're just going to hit Control tilde to open that terminal, and then we'll say cargo add. We're going to say the Tokio, Tokio, and then features equals full. That'll bring in all the features for Tokio here. And then once we do that, we can add in the macro right up here before the main function and say #, and then say Tokio main. And that will allow our main function to be asynchronous. So now if we do a cargo run, it's actually going to run our main function inside of the async executor, which is Tokio. All right, so now we need to also install the SDK for AWS for Rust, right? So if we head over to the crates.io website here and do a search for DynamoDB, you should see everything is prefixed with AWS-SDK. So right down here, you can see we've got AWS-SDK-DynamoDB. And so if you're working with other services like S3, EC2, anything of that nature, you just replace the service here after the prefix, and that will be the crate name that you install. We also need to install the AWS-config crate. This contains the core types that allow you to set up your SDK configuration, things like your credentials, your region, and all that kind of stuff. So we need to make sure that we install that as well. So what we're going to do is come down here and say cargo add, and we'll say AWS-config, and then we're going to say Just hit enter there. And then you also see this optional feature right down here called behavior version latest. This basically just checks to make sure that you are using the latest behavior of the API. If there's any breaking changes in the future, then you can actually specify which API version you want to target. But generally speaking, you can just use behavior version latest. So I'm going to do cargo add again, but specify features equals behavior version latest. All right. And then we're going to do the same thing for the DynamoDB SDK. So we're going to say AWS-SDK-DynamoDB, and then we'll just say features equals behavior version latest, and that'll bring in the DynamoDB crate. So now over in our cargo.toml file, this is our kind of crate metadata. You can see that under dependencies here, we've got AWS config with the optional feature here, behavior version latest. We've also got the DynamoDB crate, same thing with the behavior version latest. We've got Tokyo with the full feature set here. So now we're ready to go ahead and start writing some code after we set up our AWS credentials. So what we're going to do is head back over to the AWS console right over here. And what we're going to do is go to the IAM service. Let me actually just change back over to the Northern California region, because that's where I'm going to be creating a table inside of. And so what we're going to do is go over to the IAM service, and we want to create an IAM user with an access key ID and secret access key. So we'll go down to IAM users. We'll say create user, and I'll call this Trevor SG DynamoDB delete me, just so I remember to delete it a little bit later on. Then we're going to hit next down here, and we're going to say attach policies directly. So down under the permissions policies, there's actually a built-in policy there called managed policies for DynamoDB. As you can see, it's called Amazon DynamoDB Full Access right here. Normally, if you were building a production application, you'd want to create a custom policy that limits access to the DynamoDB service only if you're accessing a specific table or list of tables, right? Maybe your application needs access to, 5 or 10 different tables. So you can create custom policies that have conditional statements that limit access only to the tables that that application needs. But since I'm just focusing on the Rust code here, I'm just going to go ahead and choose full access for now, and I'll be deleting this a little bit later on. Then we'll go ahead and hit next, and we'll say create user. Now we'll click the view user button here and go to security credentials for the user and head down to access keys where we can generate some static credentials. We'll say create access key, just hit other there. And then we're going to just give it a name like Trevor SG DynamoDB delete me, and we'll say create access key. Great, so now we've got our access key and our secret key. What I'm going to do is head back over here, and I'm just going to create a PowerShell script here called creds.ps1. And I'm just going to go ahead and say $env and say AWS access key ID equals, and then we'll paste in our access key ID. And then we'll do the same thing for AWS secret access key. And then we'll go ahead and paste in our secret access key. And then the other thing we'll do is set our region. So we'll say $env AWS region equals US West 1, Northern California. So now anytime that I reset my VS Code window here, I can go ahead and just run this code right here, and that'll update those environment variables in my terminal here so that my SDK for AWS can pick up on those credentials. All right, so now what we need to do is to go ahead and authenticate to AWS using the default configuration, which is going to come from our environment variables right here. So as you can see in the documentation here for the Rust SDK, it talks about all the different environment variables that are supported. But all we need to do is to go ahead and create a client here. So what we want to do is use the AWS config crate, and then there's a function called from env, and we'll use that to just load the configuration. So back over here, we'll just get rid of this print line statement, and we'll go ahead and say AWS underscore config, and then we'll say from env, and we're going to load that in. Now, if the auto completion for Rust Analyzer isn't working, what you can do is just hit F1 to open up the VS Code command palette and then search for Rust Analyzer restart server. And sometimes that'll kick it into gear so that you get auto completion. So what we're going to do is say, I want to call load from env right here. That is an async function that's ultimately going to give us an SDK config. So we'll say load from env and then await that. And then we'll call this let SDK config equals the result. So now this variable called SDK underscore config contains an SDK configuration. So now that we've got our SDK loaded from environment variables, which we're going to be setting with the simple PowerShell script right over here, we can go ahead and create a DynamoDB client. So to do that, what we're going to do is actually rename the DynamoDB crate so that we don't have to type the full name. So if we say use the AWS SDK DynamoDB and then say as DDB, that is basically just giving it an alias or a short name that we can use to reference the DynamoDB SDK for AWS. And then we don't have to specify this really long crate name anytime that we want to use it. So I'm going to say DDB, and we're going to go ahead and create a new client down here. Let's do new. And then you can see that when we call the new function to instantiate a new Dynamo client, it's going to take in a reference to an SDK configuration. So we'll just say ampersand SDK underscore config, and then we'll say let DDB underscore client. You can use whatever variable name you want to right there. I'm just going to use DDB client because it's self-explanatory. And so now it's got this client object, and we can start to call various functions against the DynamoDB service using this client. So the first thing that we're going to do is to call the create table API. And remember that when we create a table, we have to give it a table name. We have to specify a partition key. We're also going to be specifying a sort key as well, because we have our product category, our product name. That's going to be our sort key is the name. And then we're also going to have a price field as well. And that's not going to be part of the primary key. That'll just be an additional field that we include when we write objects or documents into the DynamoDB service. So what we're going to do for starters is say DDB client dot, and then there's all these different functions. So if we do dot table, for example, you can see we've got create table, delete table, list tables, import table, update table, all that kind of stuff, right? But we want, in this case, the create table function right here. And then what this does is it creates this builder that allows us to kind of build out a request to that API before we actually send it, right? So what we're going to do is use this kind of fluent API where we just chain a bunch of methods together, a bunch of function calls. So for starters, we're going to give it a table name, and we're going to give the table name something like Stratus Grid dash products. And what I'm actually going to do here, since I need to reference the table name on a variety of different API calls, I'm actually just going to specify that as a variable. So we'll say table name and specify it as this static string down here, and then we can simply reference table name right down here. Now, beyond the table name, we also need to specify what our partition and our sort keys are. And one other thing that we have to do is specify a billing mode. So DynamoDB supports kind of on-demand usage, where if you have a really low utilization table, you can only pay for the requests that you're actually consuming. Or if you have an application that has a lot of persistent usage throughout the day, then you can pre-provision read and write capacity units to that table so that it's always got that provisioned capacity, but with the downside that you do have to actually pay for all that capacity as long as it's provisioned. So generally speaking, it's a good idea to use the on-demand mode if you're just playing around with the service so that you're not paying for a bunch of provisioned capacity that you don't actually need. Now for formatting here, since these fluent APIs often get to be very long calls, we're going to go ahead and just put a function call on each row here, each line. So we're going to say dot billing mode. And then as you can see, the fluent builder here is going to specify that we need a billing mode. And so we can either search the documentation or just rely on the auto completion. So if we head over to the docs.rs website here, do a search for the DynamoDB service. We want to find the AWS SDK DynamoDB crate, which is right here. And then if we search for billing mode right in here, you can see that it's actually an enumeration that is exported from the types module underneath the DynamoDB crate itself. So what we can do is say DDB. Let's do DDB, and then we'll go into types, and then we'll grab the billing mode enumeration. And then if we do another double colon right here, we have pay per request. That's the on-demand mode, or we have the ability to specify provisioned. So I'm going to go ahead and use the pay per request mode right here. That'll satisfy that requirement. If you leave off the billing mode, you will get an error when you try to create a table saying that you have to specify a billing mode. Now, the primary keys, the partition key and the sort key, are a little bit different here. So what we're going to have to actually do is specify something known as an attribute on our configuration here. So just to cheat a little bit, we can come down to the DynamoDB service docs under the AWS SDK for Rust, take a look at create table right here, and this will show us how to create something called an attribute definition, where we specify the name and the type of the attribute. And then we also have to declare that it's part of the schema. So we have to specify that it's a hash key in this particular case, and we can do the same process for the sort or range key as well. So we need to create an attribute definition. We need to create a key schema element as well, and then pass both of those in down here by using the key schema function on the create table fluent builder, and also specify attribute definitions. And you can add more than one because we have the hash or partition key as well as the sort/range key as well. So we're going to specify both of those. So back over here in our editor, we're going to create an attribute definition. So I'll call adder, this variable, we'll call it adder part for partition for short. And what we'll do is say attribute definition, and then we're going to go ahead and create a new one here with a builder. Then we're going to give it an attribute name. This is going to be our category. That's going to be our partition key, right? We talked about partitioning the table into different product categories. And then let's go ahead and just put that on a new line down here, put a semicolon to terminate that. And then we'll say the attribute type. And this is another enumeration here. It's called a scalar attribute type. So DynamoDB supports different scalar values like numbers, binary values, as well as string values. A scalar is a singular value. So even though DynamoDB supports things like string sets, for example, that allow you to have an array of strings, the string set or array values are not actually supported for the partition key here. So we have to choose from scalar attribute types, which is why we have a much more limited selection right here. Now, of course, the product category here is going to be a string value. So it'll be something like living room, maybe living-room, all lowercase, outdoor, all lowercase, kitchen, all lowercase as well. So what we're going to do is choose the attribute type here of S, and S is short for string in DynamoDB. So oftentimes when you're looking at the docs for DynamoDB, you'll see this S reference, and that's the string type in the DynamoDB service. So then after we specify those, we'll say, I want you to build that. And then because it's wrapped in a result here, we also have to unwrap the result and make sure that we actually get the attribute definition itself. Now, normally you'd want to do some error handling in there, but in this particular case, I'm pretty sure that that's going to work fine as long as I check the docs here. So yeah, we only added attribute name and attribute type to the attribute definition, but we also need the key schema element. So let's do the same thing here for starters. Before we do the key schema, I'm just going to duplicate this code here, and we're going to create the attr sort key. So we've got partition and sort key, and then we're going to change the attribute name for the sort key to product name. Let's actually do product underscore name. I think name is a reserved keyword. I actually ran into that when I was doing a demo run through this earlier today. And so I'm going to call it product underscore name, or maybe just product name. And then we'll specify that it's going to be a string value as well. So now we've got our sort key. Let's just indent that for readability, and our range key, or sorry, sort key and partition key. Now we can do this key schema element. So I'm going to say let key schema part equal the key schema element. And then once again, we're going to use the builder function here to create a builder. And then we're going to go ahead and just terminate that line with a semicolon. And we're going to say dot attribute name. And we're going to specify the category. That's our attribute name. And then we also need to specify the type, right? So the key type down here is of key type. And once again, you can go back to the Rust documentation right over here and search for key type. As you can see, it's under the types module once again. And this is an enumeration where we can specify either hash or range key. So partition or sort key. So we're going to say under the input here, we're going to say DDB types, and then we're going to grab the key type, and then we're going to grab the hash or partition key for this first one for category. And then we're going to call .build.unwrap again, and that'll give us the actual underlying key schema element that gets created. Then we're going to duplicate this here once again. And right down here, we'll say that the attribute name, actually, let's change the variable name for sort. And then the name is going to be product name. And this is going to be not the hash key, but the range or sort key. Range and sort key are the same. Hash and partition key are the same as well. All right, so now that we've got our attribute definitions, key schema, and all that stuff, now we can come down here. We've already got the billing mode set up. So I'm going to say attribute definitions, and then we can specify an attribute definition as input here. So I'll say adder part, and then I'll say adder sort key as well. So we're going to add both of those as attribute definitions. And then we also need to specify the key schema. So we'll say key schema and say key schema part. And then we'll do dot key schema and key schema sort as well. So we can call attribute definitions, that function, multiple times on the Fluent builder for the create table API. We can also do the same thing with key schema here. We can call it more than once, and it's just going to append those configuration objects to the internal state of that Fluent builder. All right, so now that we've done that, we can go ahead and say dot, let's see, I think it's dot send right here. And then we can go ahead and await the result. So when we call the send function here, that creates a future. And if you're familiar with Rust asynchronous operations or futures, then you actually have to await the future in order for that API call to actually get executed. If you create a future but don't await it, then it never actually gets executed, right? So we want to make sure that we await it here. And then we want to create a variable to capture the result. So we'll say let the create results equal to the result here. And then once again, it's going to return a result wrapper around either the successful operation or an error if an error occurs. Now we want to keep the error just so that we can print it out if we do run into an error. So now down here, after the create result, we're going to say if the create result, for some reason there's a bug in the IntelliSense that doesn't autocomplete down here. But if we say dot is okay, basically meaning that the operation was successful, then we'll say print line creating DynamoDB table was successful. And then we'll say else, and then we'll down here we'll do the error, right? So we'll say print line error occurred while creating table, DynamoDB table, DynamoDB table. And then after that, we'll also print out the error itself. And the way that we're going to do that is to do a special formatter here, which is :#? And then what we can do is pass in the create result dot error. And this is going to give the raw error, and it's going to kind of serialize it into a JSON looking structure. And it's basically debug output for Rust, right? So it's going to take that error object, it's going to kind of print it out in a debugging format, and we can see it in the terminal. All right. So now if we go ahead and run this, let's do a cargo build just to make sure that it compiles okay. And then after it builds successfully, we can just do a cargo run to test our program, and we should see a new table get created in our AWS account. So let's go back to the DynamoDB service in the console, and I'm just using the console here for verification of the Rust code to make sure it actually works. So in DynamoDB, in the Northern California region, we don't have any tables. And as soon as this is done building, we'll go ahead and do a cargo run. And as you can see, it says creating DynamoDB table was successful. So as long as we have our attribute definitions set up, again, you don't have to have the sort key if you don't want a sort key, but you at a bare minimum need an attribute definition and a key schema element for your partition or hash key. But in this case, we are going to be using both the hash key and the range key. And so it was successful. If we come back to the console here and just refresh, you can see that our table has been created. It's called statusgrid-products. We have our partition key, which is category. That's a string value. Our sort key is product name, also a string value. And we are using the on-demand mode so that we're not pre-provisioning capacity that we don't actually need. All right, so now that we've got the table created, we can go ahead and write some items or documents into the table. So to do that, what we're going to do, let's just actually run this again really quick so I can show you what happens if the table with the same name already exists. Then we're going to get this error right here that says that the table already exists. But we're just going to ignore that error message. We're still printing out the error message just for awareness, but we can ignore that safely because we know that our error handler right here in our if statement is executing just in case an error occurs. So we are technically handling it. You could do something else to handle that if you wanted to, just say, already exists or something. But what we're going to do is just come right after here, and we're going to be calling DDB client again. Remember, this is our Dynamo client with the SDK configuration. And then we're going to call the put item function here. And this is going to create another Fluent builder for the put item API. Now, when we create a document and actually put it into the DynamoDB table, we need to tell the DynamoDB service which table we're actually putting that item in, and we have to tell it the keys and values, or the field names and field values for each of the data fields that we want to put into the database, right? So in the case of price, for example, price would be a numeric value, but our category and our product name fields, those are both going to be string values. So for put item here, one of the first things that we'll do is just specify the table name, and we can just reference our static string right up here called table name that we defined before, and we're using in all of our API calls. So we'll say table name. That's a variable, of course. It kind of looks the same as the API call there, but it is a variable. And then we are going to just format this a little bit more nicely by indenting here. And then what else do we need to do? Well, if we take a look at the Fluent builder for put item here, let's do a search for put item and take a look at the put item input here. So we've already specified the table name, and now what we need to do is specify the item. And the item here is actually an option wrapping a hash map, and the hash map then contains the key, which is a string, and the value, which is a unique type in the DynamoDB crate called the attribute value here, because the attribute value could be a string, a binary, a bit, it could be a numeric value, it could be a string set, and things like that. So normally you can do that, but I actually checked it out previously, and what we can do is call the item function here and just pass in a key and value pair rather than having to create a hash map up front. So what we're going to do is say .item, and we'll say category, and then we'll just hard code a value for now, but we have to wrap it in the attribute value. So we'll say attribute value, and then we're going to say S for string here. Let's actually autocomplete this. So we're going to say we want the S type here, and then inside of the S type here, we want to go ahead and pass in the string that we want. So let's say living-room, for example. And I think we need to turn that into a string, so we'll call the toString function on the static string to turn it into a capital S string in Rust. And so now what we can do is say .item, then we'll say product name, and we'll do a comma here and say DDB types, attribute value, S, and then once again, we're going to say for the product name, how about we do couch? and we'll call .toString on that as well. And then finally, we'll do a price field. And the price, of course, is not part of the primary key. It's not the hash key or the range key. So we're going to say price and then DDB types, attribute value, and then N for number. And then we're going to say, how about a price of 375.0? Actually, let's just do 375. Let's see what type it's expecting here. So we actually have to turn it into a string. Let's say 375.0 and wrap it in a string. And then the SDK for DynamoDB will actually take the string here and turn it into a numeric value inside of the DynamoDB service. All right, so once again, we need to call .send here and then .await on that. We'll bring our semicolon up right here, and then we'll say let put item result equal the result of this operation. So I'm not going to go ahead and do any error handling right now. All I'm going to do is say cargo run and see if we've satisfied all of the requirements. And so down here, we get the table already exists. Okay, we expected that. And it looks like our program exited successfully. So in PowerShell, we'll say last exit code. That is 0, so that is a good sign. And so now if we come back to our DynamoDB table right here, let me close a few of these extra tabs that we don't need. Go into StratusGrid-products, go to explore table items. Now you can see right down here, items returned is 1, and the category is living room, product name is couch, and the price is $375. All right, so we know that this works now, but let's turn our Rust application into something that's a little bit nicer to insert data, right? Because right now, we hard-coded these values of living room, couch, product name, and the price for those. But if we were entering maybe 50 different products, then this would not be a great way to enter data, right? We need a dynamic method of accepting some kind of user input so that we can feed these values into our application. So what we're going to do is write a couple of helper functions here. The first function is going to be to get a value from the standard input, which is where the user can actually type into the terminal. And so what we want to do is return a string value from this function so that when the user types in some value, it gets returned back to the caller as a string value. And then we also want to go ahead and implement the code here to actually accept standard input. So if we reach into the standard crate in Rust and then go into IO and then do standard in right here, we can say readline. And we can readline into a mutable string. So we need to create a buffer first. So let's say let user input equal, and then we'll say string new. And then what we'll do is pass a reference to user input into this readline function here, and that will populate the buffer with that. But we also need to do ampersand mute to make it mutable here. And we also need to make it a mutable by putting the mute keyword right here. And so it looks like we are getting an error here. And that's because we didn't put a semicolon at the end, and it was trying to return the result from this readline function call, which is not correct. But now what we want to do is actually return the string type that we just populated in this buffer here back. So we'll say return user input. That'll satisfy the return type right here. And you also see that there's a result that comes back here. And so the readline function actually tells you how many characters were fed into it as a numeric value. So it'll give you a result wrapping usize right here. But what we can do to just discard that, because I don't care how many characters it was, I'll just say underscore equals, and that will take care of that warning. All right, now one other thing that we need to do here is actually kind of interesting. So let's say that we do something like print line, enter category, right? And then after we do enter category, then we call the get value function and say let new category equal the result of get value. So this should populate new category with a string, right? Well, let's run this and see what happens. If we do cargo run and recompile our application here, you can see it says enter category here, but sometimes that might not show up. And what can happen is that when you call println here, the buffer does not always get flushed. And so what we can do is go to standard out. So we'll go back into standard IO standard out dot flush, and that will make sure that before we call the standard input, we can go ahead and actually flush the standard out buffer. Now it looks like I am getting an error here, so let me see what is going on with that. And of course, if we just hover over the error right here, it actually tells us why it's not available. So we actually have to use the Rust trait called standard IO write in order to utilize that function on the standard out. So what we'll do is come up here and say use standard IO write. That'll import that trait so that we can use that trait's functionality. And now that is satisfied. And we'll do underscore equals again to just discard the results because we just want to call out to flush. I don't want any result from it. And that'll clean up that error there. Now, one other thing that we probably want to do is rather than putting this println statement right up here to kind of prompt the user for some input, we can actually put that right down here inside of our function. So before we do anything else, before we actually prompt the user here, we'll just say println enter category. But we're not always going to be adding a category, right? So what we can do is take a value as a string right here. And so then what we can do is dynamically print out which field we want the user to enter. So when we call this getValue function, we can pass in the value like category or product name or price, and then prompt the user dynamically based on that value. All right, so now what we can do is say getValue, and when we call that function, we'll pass in a string value like category, and then we'll do the same thing. Let's actually do .toString here because we marked it as a capital S string. And then I'll just duplicate this line a couple times and then say new category, new product name, and then new price as well. And then we'll just change the prompt here accordingly. So we'll say product name, and then down here we'll say price. And now these three variables will get the results dynamically populating this prompt right here so that when it prompts the user, we are told what we need to enter. So let's rerun that with cargo run right down here. As you can see, it says enter category, but you see it's actually on a new line. So what I'm going to do is just remove the print line and just say print, and that'll keep everything on the same line. Let's just recompile that again. So now it says enter category. We'll say, how about living-room, say enter product name, couch, or maybe a TV, and then price, we'll say 200.5. All right, so that works, right? Our prompt works to actually enter CLI input. So now what we're going to do is to call this put item result here, but we're going to pass in dynamic values rather than these static values that we hard-coded into the application code, which obviously is not a good practice, right? So now what we can do in the put item is we'll say new category. We'll just pass that string straight in. Down here, we'll say new product name. And then right down here, we'll say new price as well. All right, so now we can go ahead and just rerun our application here. And we'll go ahead and plug in some values. I did just want to show you down here, if we refresh the results in our table, right now we only have living room, couch, and 375. But if we say living-room, enter a product name like TV, enter a price of maybe, let's say 260.5. If we come back over here and refresh, it looks like that item hasn't quite entered yet here. So let's see what's going on. So one thing that we will want to do some troubleshooting here is to, of course, print out the error for put item result, just like we did with the create table result. So what we'll do down here is say if put item result dot is error, then we'll go ahead and do a debug print on the actual error. So we'll say put item results dot error, and then we'll go ahead and just rerun our application here, and we'll pass in living room, we'll say TV, and 265.6. All right, so as you can see right down here, it says the parameter cannot be converted to a numeric value. So apparently it doesn't like that decimal point on there. So let's do living room, TV, and then 265, just a whole integer value. And that's still not working. So why is that? Well, one of the things that I forgot to do right down here in our get value function is to actually trim off the new line character from our input. If we take a look at our user input somewhere up here, then when we actually input the data and hit enter, it's actually appending a new line character onto the end. So what we actually need to do is trim that off of the end of the result before we attempt to return it back to the client. So somewhere right before we return the user input here, I'm going to take the user input and we're going to say trim end in order to trim off the characters that we don't want. As you can see, the trim end function is going to return a string slice with the trailing white space removed, and a new line character is considered trailing white space, so it'll trim that off. But we need to actually take that from a static string back into a regular string, so we'll say .toString. And so now what we can do is just assign that to user input once again, and then return that right down here. So now that we've fixed that, let's go ahead and try to run our application again, and we'll use those same inputs. So we'll say living room, and then we'll do TV, we'll say 265.7, and now you can see that that error is no longer being printed out. So if we head back over here, do a refresh on our DynamoDB table, you can see that this new item has been entered with all of those values. Great. So now our application that we've written in Rust is successfully creating the table, and it's also writing objects into the table. But one of the challenges that we have right here is that we have to do a cargo run or kick off the binary every single time that we want to run the application to enter a new object, right? And that's not very efficient. So one of the things that we can do to improve the quality of our application here is to simply loop over all of this code right here so that we can continuously prompt for a new category, new product name, new price, and then write that into the table. So all we need to do in order to accomplish that is just do a loop construct right here. And then we'll go ahead and take the end right here. We'll close that off in a curly brace, and we will indent all of these lines right here. So now this little loop code right here is going to continuously loop over, getting new values and writing those values into the table. If you want to, you can actually make this a little bit nicer by changing the code to actually have a separate function. So what we're going to do is say fn write product down here, and then we're going to put our put item result down here. And all this, let's go ahead and indent that a little bit here. And so now what we want to do is to actually pass in a couple of arguments here. We're going to also need to make this async. So let's do an async function right here. And then we need to go ahead and actually pass in a bunch of arguments. We need to pass in the client reference. We need to pass in the table name. We also need to pass in the new values. So in our function definition right here, we'll say client or DDB client is of type DynamoDB client. This is going to be DDB client right here. And then we can go ahead and just reference that because it's actually the same input name as we had before. And then for the table name, we'll go ahead and just pass in a string value. We'll say table name is a string type right here. And then we'll go ahead and just leave that there. And so then we can pass that in. We also want to pass in the category and product name. So we'll say comma, category is string. We'll do product name is equal to, is a colon string. And then price is also going to be a string value, which again is turned into a numeric value by the SDK. So now we can just use the function arguments like category, product name, and price. And now we have a nice helper function called writeProduct that'll take care of writing a product for us. And that simplifies our code right up here inside of the loop. So we'll just call the write product function, we'll go ahead and reference our DDB client here. We're going to pass in the new category. We're going to pass in the new product name and the new price as well. We're also going to pass in our table name as a capital S string value here. Let's put a semicolon at the end so it stops complaining. And because it's an async function, we also want to await the result in order to get it to actually execute, right? And this function is not returning any values. So now let's go ahead and test our code to see if this loop actually works the way that we want it to. So I'll do a cargo run down here to recompile our application. As you can see, we're getting prompted. So I'm going to say kitchen. We'll say plate is 4.75. Once again, for the category, we'll say kitchen. Cup is going to be 2.40. Once again, we're being prompted again, so our loop is continuously working right here. So we'll say kitchen. Knife is, let's say, $5.60. And so we can just keep on doing this, right? So categories kitchen, product name is going to be fork, and we'll say the fork is 6.30. And so on and so forth. Now we can just hit Control-C to terminate the process here, but one other thing that we could do after we prompt for the category right here, we could say that if the new category is equal to the letter Q, like a lowercase q dot toString, then we're going to go ahead and break out of our looping construct here and return control of the program back to our main function here, right? So now we have a way to break out of it. If we go to the category and just type a lowercase q, that should terminate the loop a little bit more nicely. So now what we'll do is rerun our application. And once we're prompted for the category, we'll just hit Q, and now our program exits nicely. We're properly handling that rather than forcing the user to remember the Control-C, which a lot of regular users may not know unless they're developers, right? All right, so we have a pretty sweet application here. We're able to insert items very easily here. And if we come back to our table right here, you can see that we've added a whole bunch of kitchen items right here with the kitchen category. That's our hash key. And then we've got the product name. That's our range key as well. And then we've got the price that we entered right down here. Now you can also run queries, but due to the length of this video that it's currently at, we're at 57 minutes, I am going to go ahead and omit that, and we'll save querying DynamoDB tables for another video. But in this particular video, we took a look at how to spin up a fresh Rust project. We brought in the necessary crates, we set up our AWS credentials, we wrote the code to create tables with the necessary schema configuration, and we also wrote some code to repetitively add new products into our DynamoDB table. So anyway, that's all I've got for this video. Again, we are StratusGrid over at stratusgrid.com. If you're interested in working with us, just hit the Let's Talk button here and somebody will reach out to you. Thanks again for watching, and we'll see you in the next video. Take care.